Dear students, in this session we'll be looking at very basic important concepts required for understanding vector differentiation. The first of the concept is how to find the dot product of two vectors. Second concept is how to find the cross product of two vectors. These are basics. This does not come under vector differentiation. But without this, so many problems you can't understand. What is the length of the vector A? And some standard notations. For example, vector r is always standing for xi plus yj plus zk. This is vector r, and the length of vector r is denoted as scalar r. So this is going to become under root of x square plus y square plus z square. So let's have a quick look at these basic concepts. Suppose if I have the vector A equal to I minus j plus 2k, and vector B is 2I plus 3j minus k. Suppose these are A and B, then A dot B is component wise multiplication. So here whatever coefficient is there, that coefficient and this coefficient will multiply. So what I now do is I'll change the color to make you clear about it. That is that 1 and this 2, these are coefficients of I multiplied together, then plus. Now I'll change the color and say that this next coefficient is minus 1 and the coefficient is 3 here, so minus 1 and 3 appears here, and that 2 and minus 1, that is this 2 and this minus 1. So finally I get it as equal to, I write it with white now, 2 minus 3 minus 2, that's equal to minus 3. This minus 3 is the dot product of A and B. And coming to the second point, what is the cross product? A cross B is equal to always the determinant of the first row taken as ijk. Now I need to write the coefficients of vector A into this second row. Here in the second row I'll write it, and the coefficients of B I will write in the third row. So the coefficients of A are 1 minus 1 2, 1 minus 1 2, I'm taking from here, this 1 minus 1 2, and the coefficients of this B, that is 2 3 minus 1, I write it here, 2 3 minus 1. So actually I remove this part, so 2 3 minus 1. Now you all know that we are taking the determinant, that is AD minus BC. First AD, then minus BC. So what comes now? 1 into minus 1, that is minus 1 into minus 1, that is plus 1. Minus 2 into 3, that is 6. Minus j into minus 1 minus 4 plus k into 3 plus 2. So that is going to become the vector minus 5I minus 5, that becomes plus 5j plus 5k. This is the vector A cross B, and length of vector A is nothing but, or I'll say the length of vector A cross B. A cross B is now ready with us. Let us find the length of this one. That is nothing but square root of the coefficient, you have to take it and square it. Coefficient you have to take it and square it. Coefficient of k whole square, so it is under root of 75. That is nothing but square root of 25 into 3, that is 5 root 3. And vector r, very important point to be noted, vector r is always standing for xi plus yj plus zk, and the length of that vector r is denoted by r without any bar here. There is no bar I am taking here. So that is nothing but under root of x square plus y square plus z square. So now we will be also in need of the term dou r by dou x. Dou r by dou x is nothing but differentiating this r with respect to x. So root t derivative is 1 by 2 root t. So I'll take it as 1 by 2 into under root of x square plus y square plus z square. Then whatever t is there, that t is nothing but this part inside part t. It was assumed like root t. So I have written 1 by 2 root t, but inside that t I have to again write the differentiation for that one. I have to write the derivative of that one. So I'll write the derivative now of x square plus y square plus z square with respect to x, that is only 2x plus 0 plus 0. So finally it is nothing but x by r. So keep in mind from here onwards, whenever dou r by dou x comes, I'll be able to use x by r. Similarly, dou r by dou x dou y is equal to y by r, and dou r by dou z is equal to z by r. One thing more, sometimes we'll be in need of like this. For example, I have log r. I want to differentiate with respect to x. So first of all, I have to differentiate with respect to r, this log r, and then the derivative of r with respect to x. So this I get it as 1 by r into dou r by dou x. Just now we have seen that it is x by r. So it will become x by r square. Suppose I am in need of dou by dou x of 1 by r. Then what I do is this same 1 by r, I first differentiate with respect to r and that r with respect to x, chain rule. So I get it as equal to minus 1 by r square into x by r. That is going to become minus x by r cube. And these are some basic concepts which were required. You know how to find the dot product, cross product, how to find the length, what is vector r standing for, what is scalar r standing for, and also you have come to know how to differentiate it. What is the value of dou r by dou x, what is value of dou r by dou y, what is value of dou r by dou z, and what is derivative in this way. So suppose if I have some function of r, I want to differentiate with respect to x, then first of all that f of r I have to differentiate with respect to r, and that r I have to differentiate with respect to x. Generally we can simply write it as f dash r into x by r. That is nothing but x by r into f dash r. Whatever f of r is there, its derivative will appear here. Thank you. I hope you understood.